But let me ask you a couple more questions. So this is moving ahead a little bit, but continuity is wrapped up with differentiability. And today in ODEs, we talked about Taylor polynomials. Taylor polynomials require not just one derivative, but lots of derivatives, so you can actually crank this thing through. And so having derivatives means something. So which is stronger? You have continuity. By stronger, I mean if I require something of a function, the functions that we use in applications may not be continuous, like the Heaviside function. Represents an on and off switch. It represents a neural network firing or not firing, a cell firing or not firing. So you need those Heaviside functions, not continuous. What about differentiable? So let's call this restriction 1. Differentiable is restriction 2. Which one do you think is stronger? Differentiable. So can you give me an example of something that's continuous and not differentiable?
Absolute value.
Yeah, that's a classic one, right? You have y is equal to absolute value of x. So if you use the elementary school calculus version of what you're taught with continuity, the elementary school definition is you don't pick up your pencil when you draw the picture. Absolute value of x looks like this. Boom, boom, like that. I didn't have to pick up my chalk to draw that picture. Where is it not differentiable? Where? At the bottom, right here. You can write the way we did. How do we write absolute value in our class? Right up to the piecewise function, right?
X is greater than 0.
Oh, good. You guys have learned something. Yeah, we can stick it on. So you could actually do your elementary school calculus to find the derivative of this in pieces. What would the derivative look like? Why don't you take boards and draw me what the derivative of this looks like if you use your elementary school calculus? Everybody learn calculus in elementary school.
We're back from the hypercube.
These kind of classes or 103, and I haven't taught yet. Today, I think last Monday we asked them to program something like that, and they looked at their on it. And I asked them, how many of you have programmed in something in any course? Nobody was not just the yep class. And so I realized, oh, like I'm so used to teaching at the out of the screen. But these guys are so much. 1 year, you've learned so much.
Yeah.
What do you notice about the derivative? Yeah, so it has a jump to the continuity. So it's not necessarily that the derivative doesn't exist, it's not continuous. So that's one of the criteria of being differentiable is that the derivative has to be continuous. We call it C1 function because it has one continuous derivative. If it had 2 continuous derivatives, you have to call it a C2 function. Try another one.
No, that's the second time I've spoken about C4 thing. Don't even start. I'm afraid.
The other one that you study in calculus is x to the 1/3. Try that one out. You can actually crank out this derivative using the rules, draw the derivative, and show me what the derivative looks like. You can use Mathematica or Desmos or whatever you want.